My name is Patrick Kolsch, and I'm the Market Development Manager for Life Science and Medical Applications. Yeah, we have several of our ultrafast laser systems that we exhibit here. They vary from low power to high power laser systems. Here's a laser system that is all in one piece. It's our ORIGAMI laser that is used in eye surgery applications around the world. Then there are other laser sources that are fully fiber-based. This is our FS10 laser here. Also ultra-fast femtosecond laser system. And then we have also Picosecond laser systems that are used for different applications. Also sometimes in spectroscopy, sometimes in biomedical applications. Something that has been inspired by our customers or oftentimes requested was to have the laser light not being free space out of the laser, but yet being at the point where the customer wants to have the laser delivered through a fiber. And while this is easy if you have not a really ultra-fast laser or a femtosecond laser, there are some difficulties in doing this with particularly higher powered laser systems. And so we spent a lot of efforts over the last years to develop both the fiber systems needed to make this delivery happening for femtosecond, let's say microjoule pulsed laser systems, as well as to couple it into these fibers. And the advantage for the end user now is that he can have just simply use this at the point where they want to have the laser. You can think of in a medical procedure, it is much more easier to handle a fiber versus a very strong articulated arm. The other advantage here is that the light out of the fiber, the beam parameters will always be the same because they are defined by the fiber itself. And so if people want to change the laser, let's say in a few years into the system, they can do this easily by plug and play and putting out the old laser, putting a new laser in, just plug in the new fiber, and they are good to go. So there's no realignment needed in between two different systems. Many of these lasers here are used in medical applications, and there I would say primarily at the moment in the context of eye surgery. So when you have cataract surgery, this is where these lasers are used or come to fruition. They are in these contexts really integrated into a laser, into a medical card. That is then shipped or rolled around in the operation rooms and operation theaters. So it's really something where the laser can be now as ruggedy and is very simple to use to be used in these applications. So this is one. There are other applications in the biomedical sectors. I would say most recently and most importantly, I think, is in pathology, where these lasers are used to support surgeons during surgery to identify as to whether they have removed enough of cancerous tissue. And so this is one thing we are very excited about. That we can make now an impact directly on the life of people, in particular on the life of patients who have to undergo cancer surgery, and help them or help surgeons really to aid in that procedure so that really all cancerous tissue is removed. One aspect that I think is really unique to NKT is that we are at our core, we are a fiber company, so we are really making the fibers that go into these lasers all by ourselves. We design these fibers, and part of this results in a system that is extremely reliable. It's fairly compact, but also can be really live in all these different environments that are away from a normal lab environment, I would say. And that's particularly important today for all these biomedical applications where they are transported around in a cart, to do just that. Then of course we have really spent a lot of time making them so that their operation is stable over time, so that their beam profiles are excellent, and particularly also really reliable on the long run. It is amazing. It's growing every year. There's the new applications coming in. I would say where we are strong are in these biomedical fields. I think that we will see more in the area of aiding surgeons, in the area of pathology, in the area of diagnostics, where we be able to help identify, let's say, in cases where it's not clear, is it cancer or is it not cancer, is it benign, is it not benign, to help provide additional information there through spectroscopy methods or other imaging methodologies. I think there are other areas that I see where really little intricate features are built in medical devices that only laser can manufacture, and so in that area of medical device manufacturing, we see quite a lot of interest and growth in the future. Yeah, and I think this is already a good starting point. Of course, there's also in eye surgery new developments that happen that make these faster, cheaper, and yeah. So there's also something where we see will be new things coming out in the near future.